Alright, it looks like it's recording. So this one is about making a bunch of copies of things, having sprites talk to each other, and then this is all going to culminate by us making the game Pong, single-player Pong. If you've heard of that, hopefully you have. It's going to be fun. Alright, so it's all about building complicated programs today. So here's my first example, and you can follow along if you'd like on scratch.mit.edu. I'm going to go there. Click Start Creating, of course. See if it wants to load. There we go. Alright, so that is a nice blank canvas for us. And so here's my first example. Let me teach you about clones that allow a sprite to make copies of itself. Right? So we're going to make like a star field. We're going to make a program that simulates what it looks like in outer space when you have like a warp drive or something. So let's make 50 stars in a bunch of random spots with random sizes and directions, and we'll also make them bounce around. So this is going to be very fancy. All right, so let's make a star field, and we're going to use the cloning feature. Bless you. So this is, I guess, maybe the first example where I don't want a scratch cat. Get rid of the scratch cat. Sorry. I guess you can float around too if you want them there. But I'm going to add a space backdrop. I guess this galaxy one is cool. Stars looks cool too. Whichever one you want. And then instead of a scratch cat sprite, I'm going to go to a star sprite. I think if I search for it, it exists. Yeah, there's a little star there. So here is a single star. And the goal, what I'm trying to do here is... first of all, get my zoom window out of the way. What I'd like to do is make 50 copies of this star. All right, that's going to be the starting point. So let's generate 50 stars in 50 random spots. Okay. So how in the world am I going to make 50 stars? Well, I can add 50 sprites and like star 1, star 2, star 3, give them all separate programs, but there's an easier way. It is cloning. All right. So let me scroll down to wherever cloning is. I forget. It's called like clone myself. There it is. It's in control. Oops. At the bottom there. It's like creates clone of myself. And I'll zoom in so you guys can all see this. So if you run this block, the star will make a clone of itself. That's kind of cool. So if I click it, on the screen nothing happens, but look what happens if I drag the star away. Ooh, now there's 2. So every time I run this block, boop, 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 if I click it a few times, the original star, which is apparently this one, makes copies of itself. And they're all different. Even though there's a single star sprite, there are a bunch of copies of it now. So that's kind of cool. And then you can go back to the original format if you click the stop button. It gets you back at your original sprite without any clones. So, yeah, let's make 50 of these guys. So, well, let's make the program start when I click the green flag. And I'd like to create 50 clones of the star, so let's repeatedly call this block, right? So in a loop, repeat 50 times, create a clone of myself. Click the green flag to run it once I change 10 to 50. So that's all well and good. It's taking its sweet time, and it made 50 clones. They're all here, like 1, 2, 3. They're just all on top of each other. Well, that's no fun. All right, so let's fix that. I'll click the stop button to get to the original star again. So I would like each clone to not just be in the same spot. I like them to be in a random spot. So it looks like there's a bunch of stars all over the place. So 50 stars in 50 random locations. All right, so that's a start. And when clones are cloned, they understand, like they're sentient. They understand when their life begins. They have their own event. When this sprite starts as a clone version of itself, then you can do some extra stuff when it begins its life. So that's what I want to hook into here. So I'm going to create 50 clones of the original star, and then when each of those clones begin their life, I'm going to have them do the following. Go somewhere random. Does that make sense? Because now, when I call this 50 times, each clone will have this code running on it, because this is the event that like tells it what to do when it begins its life. When I start as a clone, do this. Go to a random spot. All right, so that is the idea. Just want to double check that we're recording. It looks like we are. So now if I click this, That's much better. 50 clones and 50 random spots. Any questions about this code so far? Yeah. Remember, I am sharing my screen on Zoom if you'd like to come and watch it. You don't have to look over your screen. So, I'll click the stop to get back to the original one, but that's not as cool as it could be. So let's make these stars, in addition to going in 50 random spots, which we've already done, let's make those stars have random sizes and directions, because now right now they just all look the same as the original one, just in different places. Let's, turn some this way. You always have a direction that you can change, right? So let's turn some. And then let's also change the size of some. Like this one's 100 size. We can make some 200 size, some 50 size. It'll all work out. So when every clone starts its life, in addition to going to a random position, please pick a random size as well as a direction. All right, so let's see here. Point in direction something. And then also, probably in looks, right? Change size or set size to some percentage. All right, so what is a direction that I want the star to point in? Well, it's some number between 0 and 360, some angle, right? I can just pick a random one. Go down here in operators. You can make a random number between something and something between 0 and 360. And so that'll give it a random direction every time it tries to do something to a clone. It'll pick a random number because it's different every time. If I keep clicking this, right? So point in some random direction. That's all the possible ones. And then also set your size to something random, please. So set size to be something between 125 and 25. I don't know. You can play around with that and figure out what works best. But that looks a bit better. So now, in addition to random positions, they'll have random directions and sizes, and it'll look a bit cooler. Isn't that nice? Any questions about what's going on there? And maybe that's good enough, or maybe you notice oh no, those were too small, so maybe I'll try a 35, maybe I'll try 115. You can play around with those numbers all day long and get it to look how you want it to look. All right, but that's a good start. Any questions about what we've got so far? So a bunch of random stars, 50 of them. The last step is I want these guys to bounce around. Remember how I made the scratch cat bounce around? We're going to use the same process. Just repeatedly go forward in your current direction and bounce off a wall if you get to one. All right? So let's make these stars bounce around now. So it's going to be a forever loop. For the rest of your lives, little star clones, please move as much as you can. Move in your current direction, some amount of steps. And then, if you ever hit a wall, bounce off of it. If on edge, bounce. All right? So that's what all the clone stars are going to do now. Forever, move in their current direction. Maybe it's this way, but if it ever gets to a wall, it bounces off. So that's what the stars are going to do. So reset, try again, and look at them all go. There they are. And of course, you can change the speed by changing how fast they move each frame, and that's the number of steps. So move 2 steps at a time, little stars, and that maybe looks a bit more calming. I don't know. Whatever you'd like. So that's pretty cool. It's working out. Are we good with this example so far? Because there's one last problem that I see that could be fixed. It's the star that was the original one, the one that started out and made clones of itself. You see how that one's not moving right now? There's actually 51 stars because we made 50 copies of the original one, and the original one's just stuck because this was its program. It's done. It just stays there. All the clones are doing fun stuff. So maybe the best way to fix this is once the original star has done its job of cloning itself, let's have it hide so that every star is moving. So let's do that. Hide yourself, please. And then just to make sure everything works out at the beginning, let's make sure at the beginning it's shown so that all its clones are shown, because otherwise that'll mess things up. But yeah, it can hide itself once it's done. So watch it, make 50 clones, and then disappear. You could start out hidden if you don't like that effect, but that's looking better to me. Now every single star is moving. All right. So any questions about either of these programs, the program for the original star and the program for the cloned stars? All right. So the last cool trick is every star has plenty of effects that you can add to it. You can change its color by a certain amount, like make it cool, change color effect by 25. Let's get it back to normal. There we go. You could also change a bunch of these other effects, but a nice effect for what we're going at is the ghost effect, and that makes it transparent. See that? Make it transparent, even more transparent. And if you know how things work, like atmospheric perspective, right? Stars that are smaller, we're pretending that those are stars farther away, right? Because things farther away are smaller. So let's make the stars that are smaller more transparent. So let's hook into the size of each star and have that affect the ghost effect on it. All right, let's watch how that works. That'll be cool. So stars that are farther away, which have smaller sizes, should have a larger ghost effect. All right, that's the goal. So we'll do that at the beginning. So I can get the size of my sprite with this size variable in looks. I can use that. Right now, this one's 100 sized. But I would like to set the ghost effect to bigger numbers for smaller things and smaller numbers for bigger things. And if you think about it long enough, there's a subtraction going on. It's like size, let's see. One of these is the right direction. It's going to be size minus something, or something minus size. And let's think of what the right answer should be. So if the size is 100, like it's right in front of me, and I want it to be a big star, and it shouldn't be transparent. So if the size is 100, the ghost effect should be, don't change it at all, change it by 0. So maybe I can start this off at the highest number. I'll just start this, I'll let it go to 100 size only. And so now if the size is 100, like the star's right in front of me, it shouldn't be transparent at all, so this will change the ghost effect by 100 minus 100, so by nothing. And then once you get smaller, like size 25 star, then it'll change its ghost effect by 100 minus 25, so it'll be only faintly there. It'll be 75% invisible. Does that make sense? So it's the biggest size minus whatever its current size is. That'll give you how much you want to change the ghost effect by. And let's add a comment for this because it's kind of confusing. So for the bigger stars, don't change the ghost effect as much. For example, if size 100 star, we want that to have 0 ghost effect, because ghost effect means transparency. Size 25 star, we'll give that 75 ghost effect. And the pattern that's going to get us there is like subtract the largest size from whatever the current size is. All right? I hope that makes a little bit of sense at least. But if we watch it work, the smaller stars are more faded, more transparent, because this ghost effect was used, it was calculated based on their size. Right? See how the bigger stars are pretty much all there, no transparency, opaque. Any questions about that? It's a cute little example, very calming. The first star just made a bunch of copies of itself and then hid. And then every clone goes to a random spot, points in a random location so it can like bounce around in weird ways, gets a random size, and then changes its transparency based on the size. We found a nice formula for that. And then forever move in your current direction, bouncing off if you ever hit the edge. All right, I hope that makes enough sense. We good to try another example? I'll of course save this for us later. All right, so that's fun. What next? Let's see here. I'd like to tell you about a concept called message passing. So this is a very common thing to do in a programming language. You kind of, in all programming languages, when we write code, we try to think about it in terms of real life things because we're humans, right? So we come up with little metaphors that kind of correspond to how humans would do things, but make them work for programs too. So the idea with this concept of message passing is that there's a sender in the program, and the sender wants to shout out something. Maybe the sender's like the scratch cat. Scratch cat. So there's a concept of a sender, and the sender wants to tell everybody something. Like, so they make a little envelope, stick their message in the envelope, give it a little stamp, and then essentially they shout it out. They shout out their message to whoever wants to listen to it. All right. So there's a concept of listeners, if I spell it right. Listeners. There can be multiple listeners for a single sender. And the idea is every listener is hooked into the Scratch Cat's megaphone and can hear exactly what he's saying. And the Scratch Cat can command the listeners to do things by sending different messages. So it's like me telling you all to do your homework or something, and then you going off and do it. I am sending a message, you are receiving that message and acting on it. Okay, so that's a very common concept in computer science. And it's going to make our little ghost example from before easier. So let's do the ghost example this way. I think it'll be more fun. Let's use message passing instead. There won't need to be a forever loop. Here's the idea. The Scratch Cat, remember, is going to be the orchestrator of it all. So like we had at the very beginning of our ghosts program, like the Scratch Cat asked the user, hey, do you believe in ghosts? And then it set a variable one way or another based on that. In this version of the program, again, the Scratch Cat's going to get, do you believe in ghosts, yes or no? And then it will send to the ghosts now. Here are the listeners. The listeners will be the ghosts, like the skeleton, the ghost, and the bat. And they will all be listening for the show yourselves, ghosts message, or hide yourselves, ghosts message. So there'll be two different kinds of messages that the Scratch Cat can send, and these guys will respond to it by showing themselves or hiding themselves. And this will make that program a whole lot cleaner. It'll be much shorter. All right, so concept of message passing. And so that, I believe, is it incensing? No, it's not incensing. Darn. All right, let me make a new program, and then we'll talk about it. So let's set the scene as before. So we had the Scratch Cat. We had a very scary backdrop of the woods, haunted. And then, I'll call you Scratch Cat. Then we had three ghosts, right? We had a skeleton. We had an actual ghost. And then, I think there was a bat. There we go. So here's the scene set all over again. And if you remember at the start, it was the Scratch Cat is asking, maybe when the green flag gets clicked, hey, do you believe in ghosts? So let's set that all up over again. So ask, do you believe in ghosts? Do you believe in ghosts? And wait. And then based on the answer, the Scratch Cat's going to do one thing or another. So we'll have an if-then-else block. So if the answer is yes, we'll do something. If it's no, we'll do something else. So if answer is yes, we'll tell the ghosts to show themselves. Otherwise, we'll tell them to stay hidden. All right? And let's see, where are the messages? It's been a semester, so I got to find them again. Does anybody see them yet? Send, stop, broadcast. There it is. So it's events. A message is an event. That makes sense. So what are messages but these things? So broadcast something. So I'm going to make two broadcast blocks here. And right now there's a message called message 1. That's not very useful. We can make other messages and give them different names. How to change the name of this one? No, I guess not. I don't see where it could be changed. So the idea is the Scratch Cat's going to shout to the ghosts a message. Hey, show yourselves or hide yourselves. So let's make those messages. So broadcast a new message called show ghosts. Call it whatever you want. And so if the answer is yes, then the Scratch Cat will yell at the ghosts, hey, show yourselves. Otherwise, we'll make another message called hide ghosts that the ghost will also be listening for. And they will be yelled at if the answer was not yes. Does that make sense? So this is, instead of setting a variable, it's shouting out a message to anybody who wants to listen for that message. And also at the start of the program, right, we should make the ghosts hidden because we don't know if the user believes in them yet. So let's hide the ghosts at the very start as well. All right, so these are messages. Each broadcast block is sending a message to anybody who wants to listen to it. And the way that you listen to a message is when you have this when I receive event set to that message. So like the skeleton, when I receive the hide ghosts message, do something. When I receive the show ghosts message, do something else. And these are just one block events, aren't they? Because what should the skeleton ghost do? I'm in the skeletons program right now. What should he do when he receives the hide ghosts message? Well, he should hide himself because he's a ghost. When he receives a show ghosts message, what should he do? Show himself. So before we were having like a forever loop that was checking for a variable to be changed. With message passing, it's so much easier. There's no need for a loop. It's just when you see this message shouted out at you, respond to it. Isn't that nice? So that's legitimately the entire program. Let's just give these two programs to the ghost and the bat. I'll just drag them into them. So the ghost also, when you receive show ghosts, when you receive hide ghosts, do those things. Okay, so these programs are going to be the same among the skeleton, the ghost, and the bat. Makes sense because they want to do the same thing. They're all ghosts. When somebody shouts hide, they hide. When somebody shouts show, they show themselves. And then it's the scratch cat that's doing the orchestrating, right? He's in charge of shouting out, hey ghosts, hide yourselves. Hey ghosts, show yourselves. All right, so again, there's a concept of a message, and these messages are being passed from a sender to any listener who wants to listen, potentially multiple. All right, so that's the setup, and let's watch it work. So we'll run the program. Do you believe in ghosts? First of all, the ghosts hid themselves because they listened for the hide ghosts block, and they knew what to do. So if I type yes, they're going to show themselves again because broadcast show ghosts happens. Each ghost knows how to respond to that message, and they respond by showing themselves. Isn't that cool? And so again, if I say no this time, they stay hidden because we broadcast hide ghosts. Technically, I don't even need this because I already hid them at the beginning, but this is just for extra effect, I guess. And so every time they see a hide ghost message, they stay hidden. So that's a much cleaner version of that same program, I would say. Don't have to have a forever loop. No need for that. Just respond when you get that message. Any questions about that? Not too bad, I hope. So yeah, that's message passing, broadcasting, and receiving. Sending and receiving, I guess, in normal computer science terms. So I'll save that. And then, before we get started on our pièce de résistance for the day, Pong, I would like to give you guys an example to work on. So take my example, what I just did. Take my ghost example. I'll give you a few minutes because we got plenty. And I would like you, if you have not recreated already, to recreate it, of course, and try to make them do something weird, do something extra. Have them like move around and haunt the scratch cat. Have them say boo when they appear. Maybe you can make a new message that they'll respond to in a different way based on an answer. Like if it's yes, do this. If it's no, do this. If it's maybe you can show half the ghosts or make them transparent. Have fun, and I'll just leave this open for like 5 minutes so you guys can copy my stuff if you'd like. But yeah, that's the name of the game. All right, here, let me give you both versions of this just right now on the slide, because then I can show you both. Come on, little screenshot key shortcut. Oh, is it not working? There it goes. I just got too much going on in my computer. So here's this code. Make it small. And then here is the message receiving and sending stuff. So I take this and take a few minutes and try and extend it or recreate it. Help each other do cool stuff. But yeah, this is how you learn. So take 5 minutes to try this. Couple more minutes. One more minute, and then we'll move on to Pong. All right. Let us move on now to Pong. I'm so excited. So we're gonna make single player Pong, and if I don't know you are not well acquainted with one of the first video games, let me explain it to you as best as I can. So Pong is all about you got a paddle thing, you got a ball, and the ball is bouncing around the screen, and hopefully you're hitting it with the paddle. That's what you can control. And so, yeah, usually you're going to move the paddle, and it's going to bounce off, but if you mess up and it like goes through, then you lose. So hopefully you just keep hitting it with the paddle a bunch of times. Boop, boop, boop. But if it ever like goes way up here, then you've lost the game. All right, so yeah, that's the game we're going to make. We need a paddle, we need a ball, and it will be fun. So let us figure this out together. Did I save this one? I think I did. It was just that one and that one. I'm going to assume that I saved it. So, or I'll save it again just in case. Yeah, they're the same size, so it was the same thing. Okay, program time. So again, sorry, Scratch Cat, you can't be the ball or the paddle. I'm going to add, there is a paddle sprite. There it is. Very small. There's a ball sprite. There it is right there. Very large. And then just to make things easier, there's also one more sprite that we're going to need, but we'll just wait for that one. So let's make this a normal size and a good direction. So like it better be this direction or something. 180. Dead on. Or how about 0 then? Because it looks a bit, that's better. It's a little wonky in the other direction. Let's make this some normal size, like 150. Is that good? I don't know. 175? I don't know what the best size is. Let's try 150. That looked okay. And so the idea is it's going to be one player Pong. So the paddle's over here, and you can move it up or down, and then the ball bounces off and has its own ideas of what to do. So yeah, here's the paddle, and so let's put it in a nice spot. And when the game begins, we or just always, right, we would like the paddle to move up and down. So there's a few ways to do it. You can hook into the up and down arrow keys. That's totally fine. Remember that we were doing that last time with the platforming game that we made. So up and down arrow keys, that's those events. Like when the up arrow is pressed, when the down arrow is pressed. You can do it that way. Or you can do it this way. You can forever be watching the mouse pointer. You can actually have the sprite follow your mouse pointer, which is kind of fun. So let me show you how to do that. So when the green flag gets clicked, or you know what? Yeah, I think that'll be good. When the green flag gets clicked, where is the mouse pointer? Dun, dun, dun. There are some variables somewhere about the mouse, wherever it is, mouse X, mouse Y. Let me find them. There they are. They're here in sensing. Mouse X and mouse Y. So like, I have to have my mouse on here for them to make sense, but like it'll be the X coordinate of where my mouse is on the screen and the Y coordinate of where my mouse is on the screen. And so if I want the paddle to follow my mouse, here's what I can do. When the green flag is clicked, just forever keep watching wherever my mouse is and go there. It'll be go to this place, go to mouse X, go to mouse Y, watch. Forever, just go to wherever my mouse is. Go to that X coordinate and that Y coordinate, because these variables will be constantly updated with wherever my mouse is. So if I click the green flag, look at the paddle. It is following my mouse. That's a bit quicker movement, too, compared to the up and down arrow keys, so I think that's better. But the game is supposed to be played in that, like, the mouse goes straight up and, the paddle goes straight up and straight down. So I only really want to affect the paddle's Y coordinate. I don't want to touch its X coordinate. I don't want to move it left or right, just up and down. So, stop the game. We only want to change the X coordinate the Y coordinate of the paddle. I hope you see why. So, set Y, let's just set the Y to whatever the mouse Y is, and it will just stay along that line now. Okay? So, no more touching X. It can never move left or right, just up or down. And so here's what it looks like now. No matter where my mouse is, it's just taking the Y coordinate of the mouse, setting that to the Y coordinate of the paddle. The X coordinate of the paddle never changes. Does that make sense why we'd want to do it that way? There it goes. So it's just forever following my mouse. And the mouse Y is a variable that keeps getting reset to whatever my mouse Y coordinate is on the screen. So that's cool. That's a start. Any questions about that? All right. So let us continue. Let's make the ball bounce off. So the ball is going to have some direction. So let's go to the ball's version of the program. So when the green flag gets clicked and the game begins, the ball is going to bounce off. It's going to move a little bit and bounce off, right, forever until the end of time. So how about this? Forever, move in your current direction some amount of steps, quickly or slowly, you can change it, and then bounce off an edge if you ever need to. So that's going to be a good start, but it's not bouncing off the paddle yet, of course. And then also, it'll be the same game every time because the direction of that ball, right, is just set to 90, or if it bounces off the wall, it's going to be negative 90, I guess. You can watch it change down here, 90, negative 90. So we'd like a different game each time, so we'd like to randomize the direction that the ball is bouncing off in. Does that make sense? We need to do that. So let us make the ball start off and point in a random direction. All right, so let's do that. So when the ball begins its life, before it starts moving, point in some random direction, and I don't know, I guess the direction can be anything between 0 and 360 again. That's fine. And now at least there'll be a different game each time. So this is the ball's version of the program. So first, before you start moving ball, point in a random direction. So now it's a better looking game, right? If I stop it, start it, the ball is going to go in some random way. It'll be a different game each time because the direction is different each time. All right, that's cool. One other thing is that if I were to start the program right now, the direction of the ball might randomly pick this way, right? And if I finish the game, it's going to immediately hit ball and make me lose. Right? So we'd like to not do that. We'd like to make sure that the ball gives us a chance of actually hitting it when we start the game. So the way to do that is to control where the ball begins its life. Make it start on the right half of the screen somewhere. Okay? And so that, if you look at the coordinates, it's like negative x coordinates over here. So we want it to have a positive x coordinate and then whatever y coordinate it wants. Okay? So that'll be randomness again. So go to set x to something random, set y to something random, but x better be only positive so that it's in the right half of the screen. And so let's go down to the random stuff. So pick a random between like 1 and, what's over here? 200-ish? That's fine. That's okay. And then the y can be anything. Anything random between either like up to positive 150 down to negative 150-ish. Negative 150 to positive 150. And so this will ensure that the ball starts on the right side of the screen, so that we actually have a chance of hitting it. So at least it's going to plop on the right side of the screen somewhere when I start the game now. But it might be pointing at us or towards the wall. It's random, and the direction is the random. Anywhere. Any angle is fine, just as long as it starts on the right-hand side. So now the ball will start in a weird spot, in a different spot, but somewhere on the right side. See? Somewhere on the right side. Somewhere on the right side. Never close to the paddle. So we have a chance of hitting it. And it's random every time. All right. And again, once the game is going, you can move the paddle. Are there any questions about what we have so far? So we've got, move the paddle back down. The paddles program is super simple. It's just forever follow the mouse pointer. The ball is a bit more complicated. It needs to start out on the right side of the screen. It needs to pick a random direction, so that's a different game each time. And then it needs to move in its current direction forever until it hits a wall, if so, bounce off. Any questions about what we've got so far? Because, of course, there's a big piece missing still. So what we need to do now is hook up the ability for the paddle to not only, or for the ball to not only bounce off the wall, but also the paddle. Because once it gets to the sidewall, it should lose the game, right? We don't want to continue. That means you've lost. So I think the best place to hook into that idea is in this loop. So just like the ball will bounce off the edge if it's there, let's make some code that is the equivalent of if touching the paddle bounce. If I hit the paddle bounce. Okay, so that's the idea. And here is the way of doing that. So it's going to be just an if. If doing something, then do something. If the ball hits the paddle, then bounce the ball off. All right. So here's how you check if the paddle and the ball hit each other. It's in sensing, I think. There is a touching predicate, or a touching Boolean expression. And you can say it's always from the perspective of whatever sprite this is, This is the ball, and so it's like if the ball is touching something, the edge or the paddle. Here is touching paddle. So right now, if I move the ball away from the paddle, touching paddle is false. But if I move the ball and have it hit the paddle, touching paddle is true. You see that? So we can use this, we can hook into this idea. If it's touching the paddle, then the ball should bounce off in the other direction. Okay, does that make sense? Because once it gets here, this will be true, and then we're going to have it bounce off. And now the question is, how do you bounce off? We got a paddle. We got a ball that has been made sure to go over here and start on this side of the game board. So the ball's going to start over here, but once the ball gets here, like eventually it's going to go and it's going to touch the paddle if you're playing the game right. How do you make it bounce off? In normal versions of the game, it's going to go this way and it should bounce off like this, right, in that direction. I will leave that as an exercise for you for now, how to figure out how to calculate that new direction, the correct direction, the bouncing off in that way. We'll come back to that later in the class, though, if you're stumped. But here, let's just make it simple. Let's make bouncing very simple, though not completely accurate to the game. If the ball's coming in this way, let's just shoot it off back that way. Just like make it do a 180. That's an easy calculation. That's good enough for us for now. So every time we hit the paddle, let's just make the ball bounce around, change its direction by 180. And that will make it move in the opposite way, away from the paddle. So that's how we'll do it. So if the ball is touching the paddle, then change its direction by 180. Point, is there a change direction block? I think it's just point in direction. Yeah. So in that case, point in direction, whatever your current direction is, plus 180. So let me get a plus block out here. Point in direction, whatever your current direction is, plus 180. So bounce off in the opposite direction. Bounce off in the opposite direction. That should actually do it. Let's watch it work. So every time the ball is stuck in this loop, right, it's going to move a little bit, check if it hit a wall. If it did, bounce off. So like if it's going this way, move a little bit, check if it hit a wall, bounce off. So like here it'll bounce off, here it'll bounce off again. So those, we'll do that. But then eventually, once it gets at the paddle, if it's ever touching the paddle after moving and potentially bouncing off edges, it will also check, hey, if I'm touching the paddle, and it's true, it'll go into the body of this if-then block and change the direction by 180. So if it was coming in this way, it's going to bounce off that way. Or if it was coming in this way, it'll bounce off that way. All right? I hope it's clear why that's going to work, and that's a bad starting game. There we go. There it goes. So now once it touches the paddle, that part of that if block inside of that loop is going to make it bounce off. Whee! Any questions about why this code is creating this effect? It's really cool, isn't it? Nice little game we've made for ourselves. So the bouncing is not quite accurate to the original, and I encourage you to think of the formula, that's not plus 180, to get it right. We'll talk about it later in the class, though. So, yeah, this is the balls program, of course. Very fancy. Point in a random direction, go on the random, get a random spot on the right half of the screen, then repeatedly move, bounce off an edge, or bounce off the paddle. And then the paddle has a very easy program. It's just forever follow the mouse. The ball is taken care of, like bouncing itself off. All right. So now, the only thing that's left to do is have us lose the game. Because if I miss the ball, it should not bounce off the left side of the screen. Right? It needs to stop the game. And oops, that might be a bug. But, well. So that is the last piece of the puzzle. And you can't really check very easily if I hit the left wall with the ball. You can do some weird, like, check the X coordinate stuff. But it's easier to just add a sprite. Here, let me show you the secret. There's a nice sprite called line, I think. Just a big long line. H-I-J-K-L. There it is. Just a giant line. Did I click it? Maybe my internet's slow. Well, I'll search for it and add it again. Ooh, that's really weird. Maybe my internet's not working? I would like to add that sprite very much. Please. Line. Oh, man. Well, that's never happened before. Maybe if I change something up again, choose a sprite, line. Sounds like we found a bug in Scratch. Well, alright, let me save this, assuming it's letting me. I'll reload Scratch. Leave the page. One way or another, I'll make this work for us. And yeah, it does look like I lost the internet somehow. So, at least you guys can still see my screen. I think I'm going to have to do some weird stuff here if it's unhappy. Hey, why is that above everything? There we go. So, it thinks that there's internet, but it really doesn't see it. So let's see if I can go to another website. YouTube. Alright, that's not working either. So it looks like the internet is the main issue here. So let me stop my internet and turn it on again. And I have a feeling this is going to mess with did it in my other class too. It'll mess with the display because it's like a wireless connection to the screen. Sorry about that. Just give me a second while I figure that out. Okay. Not very happy, but I'll try it again. Come on, little projector. You can do it. It thinks I'm connected, which is hilarious. Oh, there it goes. I think it's figuring it out. So that's what I get for having wireless internet. You guys all have wired internet right now. There we go. Sorry about that. Alright, so let me load in the file that I saved. Alright, and then really quick, I'm going to add a line sprite. Come on, you can do it. Yay! Alright, it's there now. Thank goodness. So here's my line sprite, and I want it to actually be the other direction, so I'll change its direction to 0. And here's the way we'll do this. We'll put it right here, right when I want it to lose, like make us lose the game. Does that make sense? So if the ball ever touches this red line now, that'll be the way this works, then the game will stop. Alright? So that will be how we do this. So when the green flag gets clicked, this line, I'm on the lines program right now, it will forever be checking, hey, is the ball touching me? If so, the user just lost the game. So forever, keep checking and seeing if the ball is ever touching me. So we're going to have a touching ball little piece, and we'll use an if as well here. So forever, each time, each new frame, check and see if I'm touching the ball. If so, then the game should end. Right? So here's one way to make the game end. You can use the stop block to stop the game once you lose. There's a block called stop, and it's right here called stop all. And you can see how it ends the program because nothing can go underneath it. There's no little wedge for things to move underneath it. And so that'll stop the program if we ever get here, if it's touching the ball. So if I play correctly, give me a better starting point. There we go. So I'm playing just fine. This is the lines program, by the way. The line keeps checking, hey, is the ball touching me? Hey, is the ball touching me? It's still not touching it yet, but if I miss, and I'll do that now, then it stops the game. Now my mouse does nothing, the ball stops moving, it stops the program. Does that make sense, how that's working? And if I start it again, it'll all be brand new, bounce off, and then if I lose again, it'll stop it. I tried so hard to lose right there. There. Again, it'll stop the program. But yeah, that's essentially the game. We can clean it up a little bit. You can make your own sprites. I don't know if I showed you this yet, but let's make a you lose sprite that displays itself when the user loses the game. I think I'll make it as, we'll just make a sprite. Oh, sorry. I don't want to make one from the catalog. I want to paint one right here with the paint button. And so I'll make some text saying, you lose, sad face. And you can make that as big or as small as you want. Whee! Make it giant. And yeah, that'll just display when you've lost the game, I guess. So go back to the code. Here's the you lose sprite. Of course, we want to start it out not being shown. So when the green flag gets clicked and the game begins, hide the you lose sprite. But when we lost, it should show itself, and it's the line who determines that we lost the game right before it stops everything. So again, the easiest way to make another sprite do something for us is to use a message. So in events, we can broadcast a game over kind of message or something, and it'll be the game over sprite that listens for that. I'll call this the you lose sprite. So whenever I receive the game over message, I'm going to show myself and just mock the user a little bit. All right. So now we have a complete game. The line is the most important thing now. Start the game, and then when I lose it, it shows that you lose. So at the very beginning, like it's all fine. Start the game. and I can play as much as I want, but once I lose and the ball touches the line, then it's going to broadcast game over, which is going to make the you lose sprite show itself, and then also it'll stop the program so that like the paddle can't move anymore, the ball can't move anymore. And you can restart with the green flag, of course. Okay. Oh, is that a... Oh, that's a little bit of a bug, isn't it? So, let's see here. I have to click it twice to actually start the game all over again. So there's some issue there. Let's see if we can find it. I have a feeling that when I click the green flag the first time, because the ball is touching the line, it makes me lose all over again. That's kind of funny. Let's see. What would be the easiest way to fix that? I don't know. We can make a new message, maybe. We can call it, like, new game. And then I'll make it hide itself. And then at the beginning of the program, maybe it's the line's job, I don't know. Somebody needs to say, hey, it's a new game now. And that will make sure to hide that thing. There we go. So the line is broadcasting at the very beginning. It's a new game, which is calling the you lose block to hide itself. And then it'll say game over if we ever lose. And that will cause the you lose block to show itself. So it's responding to these two messages, new game and game over. All right. So you got the paddle, which is easy. Just follow the mouse pointer. The ball, which is doing some fancy stuff. Random spots, directions, moving, bouncing off both the edge and the paddle. And then the line is being like controlling the you lose sprite, new game and game over, and then just always checking to see if the game is finished yet. Because if the ball is ever touching that line, game is over. All right. Any questions about this Pong game? I think that's everything I wanted to show you. Definitely extend it. I'll give you all this code, of course. Save. I'm going to give you several copies of it, apparently, because of that weird thing. But I think that'll fix it all. Yeah. So if we're good, that's everything I want to talk about here. It's a new week, and so I think you have a new programming assignment, like I said, so let's release that now, too. Programming assignment 3. And I probably lost the internet all over again, so we'll probably have to play this game again. Sorry. Of course. I don't know what's wrong with the wireless internet today. It was bad yesterday, too. Well, I will eventually show you your assignment. I guess I'll have to reconnect to the internet again. Sorry about this. Gosh. I don't understand it. What if I can try this one? And again, it's most likely going to hit me off of this. Yeah, try it. At least it still has the display on, so you just get to watch it try to connect to the internet. Let's see if this wireless one works. Okay, cool. I don't actually know if it published because of how I clicked it. So I'll reload that and make sure it's published. Of course it's not. There we go. So now it's published and you should be able to see it. So if you have never programmed before, here's your assignment. Well, while the internet lasts, there is a fun little tutorial for Scratch that makes a Space Invaders style game where you've got like a little turret gun at the bottom and like you're shooting stuff off. Like there it is. I don't know if I'll be able to find an actual demo of it, but here's like, here's the dude playing the game kind of. Things falling, those are your enemies, and then you can shoot at them. That's kind of small, but you'll watch this. I'm forcing you to watch this video, and so you'll create your own version of the Space Invaders game, all right? Just follow the instructions and make your program. You can change it as much as you want, like instead of the aliens that you're shooting being tacos, you can turn them into whatever you'd like, as long as everything that the man talks about is there. As long as all those features are in there, you can change up the game as much as you like, make it your own. So that is your assignment, and of course I want you to upload a video, show me it working, show me you understood what he told you to do rather than just blindly followed those instructions, etc., etc. Does not have to be long. So same as before, turn in a video explaining your code and walking me through how it runs. And so that is your assignment if you're on the Scratch assignments. Any questions about that? Follow the instructions, have a fun time. Otherwise, if I have not given you a custom assignment and you have programmed before, here is your assignment. You're going to go through these sections of the book and do exercises 9 and 11. So you should be making some cool stuff and give me a video showing me that you got it all working. Yeah, so that's your assignment otherwise. Any questions about that or anything else for the day? All right, in theory, this is on Canvas now. So, yeah, that is your programming assignment, and it should be published. Let me just confirm that by reloading this page. Come on. Okay, yes, you're able to view it now, I think. So, yeah, that's officially all that I've got for us today. The rest of the time is yours to work and ask questions.